Alright guys, welcome back. So let's move on to the constraint network applied in the simulation. Before we do that, maybe we can drop down a node, right, to reference that. Let's name this constraint net. Cool. Now go back to distraction simulation here. I'm gonna right click beneath rigid body solver. We're gonna apply a constraint network. Alright, now this constraint network also needs the constraint relationship. So let's create a merge here. We have two constraint names, so we can create two constraint relationship. So they're all glue constraint relationship. Okay, I'll drag to duplicate. Okay. Now let's name the first guy strong, the second guy weak. The stronger one will be again glue strong as the name, and the weak one will be named glue weak. Alright. So now let's go back to the constraint network and apply the constraint net right here, and we should be able to see the constraint network being visible here because we do have the guide on. We can actually change the color of the strong one to white, right, and the color of the weak one to be black, just to get the same results, the same kind of like web we're having before. Okay, now they're completely loaded without any problem, but if you do have some problem, check the data name, see if you have any typo, check if you have checked in there, if you have loaded in the correct node, and here underneath attributes Rango for the constraint network, make sure that you're doing that on primitive level. Make sure that this name is exactly the same of the ones you typed in again, right here. And eventually, one more thing you want to check is, are you using the same name here, constraint name? That has to be constraint name. If not, then the constraint network will not be able to recognize it. Okay, make sure that you check those things. If you do have any problems seeing the preview of the constraint network in the dot network. Okay. Alright, now with that constraint being applied, let's play the simulation. You can see now nothing is actually changed. The glue are holding really strong. The reason for that could be, we could assume that's because of the strength is really high, right? So let's zero it out on both constraints. So they have zero strength, meaning any collision should be able to break it. But if you play the animation again, it's still not gonna break, because as far as rigid body is concerned, actually the bullet solver we're using here, as far as this guy concerns, force doesn't break glue constraint. Okay, so you have to tell it to break. To do so, we need a subsolver. Subsolver here on the constraint solvers, right, of this constraint network. Instead of it, if you go to the relationship geometry, we see the constraint network, and that's what the constraint network is. It's constantly updating when it's simulating. So we do something here, it's gonna be updated. Alright, so let's create an attribute Rango to actually break it when the force applied to the pieces is stronger enough. We do have forces if you play through the animation. And go back and take a look at the geometry spreadsheet. I look for force. You can see we do have forces. Before frame 5, right, we do have all those different forces. Some of them are like that strong, right? So here we need to know that force. To do so, we have to reference in the pieces. So object merge will be the one we use. And here we're merging in the object, the geometry we were checking in earlier. So RBD packed object geometry accepts. Okay. Now we can see all those attributes, including the force again on this geometry. Again, those are the pieces we're simulating right now, and they will also keep being updated down the way. Now we can use that as the second input. Then we can check in attribute wrangle on the primitive level. We're gonna ask for every line we're iterating through the constraint network, we're gonna find the pieces around it and see the force. And if the force is stronger enough, then we break the constraint network. So I need to know the pieces. The pieces are points, as you can see now. They're packed objects, right? So I need to look for the near points. Int near point none will be equals to near point. And I'm going to ask the second input, and I'm going to ask for from the current position of our constraint. Every single line, we're going to ask the nearest point, and then we're going to ask for the force on it. So vector force applied will be equals to point first input, right? We're gonna ask for the force on the point, so force will be the attribute we're asking for, and then we're gonna ask the near point we just found out, right? And then let's say float strength or force magnitude will be equals to the length of that force applied vector. Now if the force magnitude is bigger, right? Force magnitude is bigger than the brake force. Okay, the brake force is something we created very earlier when we were doing the constraint network in the attribute wrangle. We created this brake force, right? Now that attribute carries along in the simulation too. Whoops. So here in the constraint network, right, we do have that brake force attribute here on the primitive level, right? So we're going to ask if the force magnitude we just calculated from the near points and see if it's stronger than the brake force we defined on the constraint. If they are, then we break it. One of the ways we can do that is remove the primitive. So remove prim, right? I'm going to remove it, and that's going to be ourself now, the first input. We're going to remove the primitive we're iterating now. Prim num, right? And then 1 here for the last argument to define. Do we also delete the point connected to it? 1 means to delete those points. Alright, so now we have removed the primitive when the force is stronger enough. Now the force is something ranging from 0 to 20 as we have checked before. So here, back to the attribute wrangle, we can use that information to define like the brake force of the strong and weak. So let's say the strong brake force will be, how about like only like 18, so only the strong ones will break, right? Weak brake force will be just 1, so a little bit force will break all those weak guys, right? Let's go back to the subsolver. One last thing here is we drop down a output and drop down the visibility to the output. Alright, cool. Let's go back to frame 1. We got an arrow which is cached in Salco clean in immediate mode. Cache without is incorrect. It's probably okay. Let's go play the simulation. As you can see now, the constraint all breaks, right? after we start to simulate. Now that's not what I want. I do want them to be break a little bit, but not like all together right away, right? Everything here disappears after just a little break. Now that could be because our glue constraint, remember that we changed that to 0 before, right? So let's say glue strong will be needing 150 and glue weak needs maybe just 1. Right. Now let's play it again. Because see, now we're breaking. The weak ones are break, the strong ones are still holding over here, so they're falling down. But when they're falling down, because the collision between pieces, some more should break too, right? So now we have this network that does, you know, make the simulation a little bit more interesting. Okay, you can see how the pieces are holding together, right, while the weaker ones are bricked. See that again? You see the black ones disappears. Kind of want the black one to hold for just a bit more. So I'm gonna say, how about let's also make the strength just a little bit higher, like maybe 5 for the weak, and also underneath subsolver here. Oops, actually go back to the constraint network. We can say, how about 5 for the break force of the weak guys, so not all the weaks are gonna be break in the first blast. Okay, I want them to be breaking gradually down the way. So let's play it again. That part breaks. That's not what I want. They're too strong now. So I just need to find that sweet number that I want to use. So here, glue weak, let's do maybe only 3. And then here attribute wrangle on the strong and weak break force. You know what, let's control these two actually somewhere else underneath in the simulation, so we don't have to jump back and forth. Underneath the merge, let's go add, actually on the subsolver, wherever you want to apply it, right? So I'm gonna create parameters, 2 float parameters, and this one, let's call it strong break force. And this guy, weak break force. Right. Let's apply that and accept. So now we have 2 things here. Oops. Forget to label that. Accept. Okay, so we have those 2 now. Let's copy parameter on the strong one, go back to the attribute wrangle, we can paste it here. Just makes things easier if we can just toggle or tweak everything right inside. So here I'm gonna also copy parameter here for the weak guy, back to the attribute wrangle. I can also use that to control this channel. So now they're back to 0 now because they're 0 here on the subsolver. And then I can say strong break force. Before we're using 18, right? So I guess it's okay, maybe just a little bit weaker. 15. Weak break force was 5, it's a little strong. Let's try 4, Let's try it again. So now it's just going back and forth and trying to figure out the correct number for these guys. Okay, those are holding together too strong too. So go back. I need the break force to be just a little bit weaker, like maybe 12 for the strong. I want those guys to disappear like more when we do that initial blast. Okay, it seems to be doing a good job. Let's go back to 15. Maybe that's because of our glue strong is a little strong. So let's try 100 and glue weak, maybe back to 2. Still not doing a very good job. I really want to see that initial blast. It's not really not showing me up. They're holding together too much. So here the weak break force, let's change that down to 1, so they're breaking sooner. And strong break force 15, I guess it's okay. Glue weak here, let's change that to 1 just to make them easier to break. Maybe keep that to 2. I'm not sure which one is the value that really does make a difference. So again, when you get to in this stage, when you're finished the setup, it's now really the time to tweak, adjust, and then tweak again and adjust again until you get the proper result you want to get. Okay. And even change the force if you wanted to. So I don't quite like that part. I really wanted to blast out. So here, weak break force, let's change that back to 0.5. Really weak force can break it. Right. Okay, so stronger forces here, stronger glues here maybe can break also a little bit sooner. Let's change that to 10 instead of 15, maybe even smaller than that, 7. Okay. So you don't have to copy the numbers I'm having. Right? What you really wanted to be able to copy or understand is like what I'm thinking when I'm doing those guys, right? I want those break blasts to be stronger, so I'm taking the breaking force to be smaller so they do break. But if I want the other parts to hold together more, I can actually go change the glue constraint relationship, right? And we can really define them here, like the strengths for the weak to break is 2. For the strengths for the stronger ones, we can change that to, if you wanted to hold everything together, we can make that higher. And then this part will break immediately because the force breaks them. But the other guys are having a much stronger force to hold, so they don't break that soon, right? You can see they're still holding together on these parts. So a lot of cool things we can do here to make the simulation looks completely different. So I do encourage you to spend some more time on this part, right? Find out the best result you are looking for, and then we can move on to actually uprising the resolution of our pieces. Okay, so that's gonna be it for this guy, this tutorial. In the next one, we're gonna move on to uprise our geometry. Okay, see you next time.